we're looking at curve sketching, but just by purely looking at values of y, values of y dash, which is the first derivative. Remember, the first derivative is the gradient of the function, and looking at y double dash, or the second derivative, which gives you the shape, whether it's concave up or concave down. So what we're going to do, it says complete the following table, stating whether the values of y, y dash, and y double dash at the points A, B, C, D, and E are either positive, negative, or equal to 0. All right, let's look at point A. Okay. All right, what about, so this is y, this is the y-axis, this is the x-axis. Tell me about the value of y. This might be, say, -2, 3 or something. Tell me about the value of y. If this is the point, imagine it's got a negative x coordinate, a positive y coordinate, the value of y. Positive or negative? Positive. The value of y at B. It's positive. C, the value of y is D and E, 0. So that's just the value of y. Now, y dash is the gradient. Now, look, I think this looks, does it look like a horizontal inflection? It might be I think it might be. It might be. I think that's a horizontal inflection. Yeah. Whereas that's an ordinary inflection. Can you see that? So at A, I'm thinking that the gradient's flat. Yes? So equals 0. We're thinking it's a stationary point. What about at B? Tell me about the gradient. Negative. So at B, y dash, the gradient's negative. At C, the gradient's 0. We okay with this? At D, the gradient's 0. So anywhere where the gradient is 0, that gives us our stationary points. Remember, for stationary points, y dash equals 0. And at E, the gradient is negative. Or did I put that? Yeah, negative it is. Negative. I can put negative. Do you think I should write negative instead of less than 0? Whatever. Now let's look at y double dash. At A, look, concave up, concave down. This is an inflection. Look, concave up, concave down. Concave up means second derivative greater than 0. Concave down means second derivative less than 0. There must be a second derivative equal 0 between them. That's a point of inflection. So that second derivative there is 0. Here we have a horizontal inflection because the first derivative equals 0, the second derivative equals 0, and I can see a concavity change, concave up, concave down, right? At point B, let's have a look. Concave down, do you think this is concave up? I think it might be. And concave up, we have an inflection as well. Look, concave down, concave up. So this is just an ordinary inflection, not a horizontal one. What about C? Tell me about the concavity here. Smile. Concave up. Second derivative greater than 0. It's concave up. Can you see? So it's a, what is it, a minimum? A minimum turning point. Because first derivative equals 0, and when you work out the second derivative, we can see at that point second derivative would be greater than 0. Tell me about D. It's a maximum. It's also at concave down. Maximum turning point. Remember, can you write maybe here next to that concavity? We're determining that by concavity. This one is purely gradient. And this is the y value. All right, and E, well, I think it's still part of concave down. Can you see? So I think, unless, we don't know what happens here. If this comes back up, but I don't think it is, I think it's just down all the way. I think that's concave down. Because otherwise it would be, you know, may start coming back up. I'd say it just keeps going. Okay? No special point there. All right? So you might want to be putting, you know, for this bit, y double dash, concave up for that section. Do you know what I mean? For here. For this section, y double dash less than 0. This is up again. For this section, y double dash greater than 0. Concave up. That's, oh, there would be another inflection here, you know, but they didn't mention it, all right? There is going to be another inflection there. Look, up, down. There will be another inflection here. Sorry, I should put y double dash, but it doesn't matter. All in this section, y double dash less than 0, okay? All in that section, up, up. See? What you might want to do is colour it. You know, these are all my ups. These are my ups. Oh, I probably should do ups in another colour. You might want to highlight the ups and the downs in another colour, etc. Are you okay with that? Can you sort of see it? So you can do them in a different colour. I might just do all the ups in one colour. These are all my ups. Concave up. So I got up, that's down. That's up, the rest is down. So all the ups are shaded in red on my diagram, and the downs are not shaded. Here are my concave downs in blue. So anything blue is concave down. See, okay? Down, down. And anything red is concave up. This video today is for Mia, who has other commitments. We're given the graph of a function. We don't know what the function is, but you could imagine this is like a y equals x squared type of graph. It's obviously off center. And we're going to sketch the gradient function. Now look here, that says function of x, x, whereas this axis, the vertical axis now is f dashed x, which is the gradient, and this is x. Now, what we're going to do on your original diagram, tell me about the gradient here, positive or negative? Negative and steep, negative but not as steep, 0 gradient. So what I'm going to do? Negative, the gradient's negative, negative, negative. Smaller negative here, the gradient's 0, you okay? Slight positive gradient, look, and bigger positive gradient. So I'm going to sketch what I think those values might be down here. At this particular value of x, I have a gradient of 0. Now the thing here is we've got to decide, how do I draw this line? Do I draw it as a straight line or a curve? If you imagine this to be y equals x squared, I know it's not exactly y equals x squared, but it is that type. Wouldn't the y dash be what? Y dashed is 2x. So do you think this is going to be a straight line? It is. That's how you know. Okay, so, but look here, I've got a 0 gradient, I've got a small positive gradient and bigger positive gradients. So this might be positive gradient 1. Look, if I look across here at this x value, my positive gradient's bigger, because these might be values of gradient here. That might be 1, 2. Can you see as I go up, at this x value, my gradient is a lot higher. Okay, and I just go down here because look, I've got a negative small value, negative bigger values at this particular value of x, etc. So the gradient here might be negative 5, negative 4, negative 3, negative 2, negative 1. Negative 1, negative 2, negative 3, negative 4, negative 5. Like looking at these values, negative 1, 2, 3, 4, 5. At that particular x value, you're plotting what the gradient is. All right, so if it's parabola, the next derivative gives you a straight line. That's how you know the shape. Okay, now this one, let's go down here. Okay, so this is a straight line. Next one. What could a possible, this is a straight line. So this might be y equals 2x minus 1 or something, because you know it's a little bit low. If this is of a straight line, let's say you differentiate y equals 2x or y equals x, what do you get? Y dashed is a constant. Is this gradient positive? It is positive, but it's the same gradient all the way. So for this section, the gradient is some positive value. I do not know what it is. So the gradient along here is the same. So what I'm doing is sketching the gradient. And the gradient there might be, I don't know, it looks like a gradient of 1 to me, roughly. So I say where f dashed x is 1, for these x values, the gradient's 1. See, I'm sketching the gradient function. Now, tell me about the gradient here. Actually, you can't differentiate at corners. Sharp corner. In a curve, it is not differentiable at that point. So coming down from there, I need an open circle. Now, tell me about the gradient here. Negative. Do you think it's a steeper negative than that one? Well, that might be gradient 1. This might be gradient -3 or something. So when I say the gradient, like that might be 1, I probably should have drawn that a little bit further down, but this gradient is a lot bigger and negative. So I've got to draw for this section from there to there. My gradient would be down here somewhere. Do you get that? I might say the gradient is +1, but I might say here the gradient's -3 or something. But it's the same gradient all the way. It's a constant gradient. Do we get that? And then tell me about the gradient here. Would this be hard to walk on? It's easy. It's flat. It's got no gradient. Gradient 0. Rise 0, run plenty. If I want to do the gradient from there to there, rise 0, run. So there's no rise. So the rise, you know how gradient is rise over run? A flat line, horizontal line, has 0 gradient. So from there onwards, so that's corresponding with that point, and it's directly above that one, the gradient's 0. You okay with that? It's flat. So this is the line. So this might be the function y equals -2. Differentiate y equals -2, and what do you get? 0. Remember, this is the derivative of that. That's like a positive x, like y equals 1x. Differentiate that, y dashed is 1. This might be y equals -3x plus something. Differentiate that, you get y dashed is -3. So girls, that is directly below that, and that's directly above that one. All right, let's look at number 3. Okay, points of discontinuity. Now, okay, tell me about the gradient here, or here, or wherever. What about the gradient at this point? Let's look, come on. What's the gradient there? 0. Tell me about the gradient. Negative, very steep negative. Negative, but not as steep. So negative, okay. What about the gradient here? Slightly positive, a bit more positive. That would be the most positive. It's still positive, but not as steep. Like if I'm doing a tangent, look, it's positive gradient, positive, but then it goes less steeper again. This is slightly positive gradient, but tell me what the gradient's approaching here. Isn't this approaching flat? This is almost becoming flat. So what's happening to the gradient here? It's approaching 0. Like you've got a bigger positive gradient there, but then the gradient's approaching 0. Now, that's your biggest positive gradient right at that point, and then it's still positive, but it's getting smaller, and these are really tiny positive gradients. So I've got a fairly big negative gradient. At this point here, I've got gradient 0. So this is mapping gradient. So my gradient here is 0. My gradient here is negative. Now, so I'm just going to draw like a line that goes like this. Now, the gradient's positive, and then a bigger positive, and then smaller positive. So I'm going to reach a maximum positive gradient about there. Because pretend this is gradient 1, gradient 2, gradient 3. So it'll come like this. That's my biggest positive gradient. But then doesn't my gradient's still positive, but it gets flatter and smaller and approaches 0 again. So my gradient comes back down here and approaches 0. How are you with that? You've got to sort of put values. For this particular x value, the gradient's 0. For this particular x value, you might say the gradient's -1. For this particular x value, you might say the gradient is -2, like along here. For this particular x value, you might say the gradient's -3. Look, -1, -2, -3. For that x value, the gradient's -3. For example, I'm just making up numbers. For this particular x value, the gradient might be a half. For this x value, the gradient might be 1. So I've got half and 1. But now the gradient's a half again, so back down here. And now the gradient's getting really close to 0. So just imagine these are 0.1, 0.2, 0.3. Gradient's getting smaller and smaller and approaching 0 again. That's what you've got to imagine values. So we're saying for this x value, the gradient is 0. It's positive. That's the biggest positive gradient you've got. Do you see? That's the biggest positive gradient, like you're reading the value across here. All right. Number 4. Girls, tell me about the gradient always. Positive. Very small, but almost flat. Gradient here is positive, but almost 0. Small positive, getting bigger, getting bigger. So, small positive for this. So for this particular x value, I've got a very small positive. For this particular value of x, it's slightly bigger. For this particular value of x, it's slightly bigger. Girls, it's the same curve, pretty much. Pretty much. And you know why? You're going to learn later that this, it's like this could be y equals e to the x or something like that. But normally it's a little bit steeper. But when you differentiate, now e is the number 2.71, whatever it is. When you differentiate y equals e to the x, you get e to the x. So, but you, with this small positive value, slightly bigger, the gradient's just still positive, but just getting slightly bigger all the time. It's pretty much the identical curve. Okay? All right, let's have a look at this. From your knowledge of extension 1, wait, tell me about this, ladies. A negative, isn't this like, no, a positive x cubed graph, isn't it? Isn't that the x cubed type shape? Not just x cubed on its own. Normal x cubed is like that. This is like x cubed plus 2x squared minus 4x plus 5 or something, or plus 0. You know, from polynomials. That's an x cubed type curve. When you differentiate x cubed, what do you get? If I had x cubed and I differentiate it, what do I get? All right, x squared type. So we're expecting when you differentiate this is the original function, it's the x cubed type. Even if it's that plus 2x squared, doesn't matter, this will still be plus 4x. It just means it's shifted off center. It's still a parabola. We're going to get a concave up parabola from this. Let's see. Tell me about the gradient here. Here. Tell me about the gradient here. Positive and big. Big positive. Is it getting still positive but not as steep, smaller positive? Tell me about the gradient in this whole section. Negative. Where's it the steepest negative it can be? At the something. Concave down, concave up. At the inflection, that's the steepest negative gradient that you have. Because look, watch. Negative, and then it flattens. It's still negative, but not as negative. So, still negative, smaller negatives. What's the gradient here? 0. And then 0. Small positives, big positive gradient. Do we get that that's the steepest negative that you'll ever get at that point? Gradient's still negative. Look, watch. 0 gradient, negative gradient. That's the steepest, then it's not a steep negative anymore. Do you see it? So at this point, yes, the gradient's negative, but it's the steepest it will be. So down there, I'm going to go. What about the gradient for this x value? What's the gradient at this x value? Look, guys. So at this x value, corresponding x value, see f dash x, the gradient 0. Give me the gradient at this x value. Guys, look, positive gradient, 0 gradient, negative gradient, 0 gradient. So what I like to do first is before I start, see where the gradients are 0 and mark them here. Because see, at that x value here, f dash x, the gradient 0. At that value of x there, so come across the same place on the x-axis, the f dash x, the gradient 0. At this particular point, I've got the maximum negative gradient that I can get. So watch, positive, big positive gradient, smaller positive values, zero gradient, the maximum negative gradient down there. Still negative, but not as big. I've got zero gradient there, and I've got positive gradient there. What have I just drawn? A parabola. Does it make sense? That's an x cubed type. This is an x squared. Okay, this one. What type is this? The W. 4 pieces. 1, 2, 3, 4. It's the what type? X to the power of 4 type. So you're going to get a cube. Probably like this. We should end up with something like that. Okay. Tell me about gradient here. Positive or negative? Negative. And big, steep. Tell me about the gradient here. Watch my pen. 0. Tell me about the gradient now. Positive. You know, this is a lot steeper than that is. So positive, positive. Where's the steepest positive? Concave up. Where the change in concavity is, that's your steepest positive there. Do you see that? It's still positive, but not as steep. Tell me about the gradient at this point. 0 gradient. Tell me about the gradient here. Negative. Where's the steepest negative? Where it decides to become concave up again. So that's my steepest negative. Then I've got smaller negatives. Then I've got 0 again. Then I've got, look, 0 gradient. Then I've got positives. Now, what you do first, you want to mark in your zeros and your steepest positive and steepest negatives. They're your turning points down here, sort of. So where are my 0 gradients happening? There, there, and there. So come down here, 0 gradient. See, because this is mapping my gradient versus my x values. I've got a 0 gradient there. And I've got a 0 gradient there. Okay? Now, you okay with that? Tell me where the steepest positive gradient is. Here. So you're up here at the steepest. So it'll be like this. Because these are still positive on either side, but not as big values. The steepest negative is here. I think that's not as steep. This is not as steep as that. So just a little bit, not as far down. So can you see what's happening? We've got this. Then I've got small negative, bigger negative, smaller negative. And I've got positive values for gradient up there. And down here, my gradient's negative. Small negative, bigger negative values. We ended up with the cubic like we said. Do you understand this? And look here. The first derivative tells you about the gradient of the curve. At this point, it's positive. The steepest positive it can be. The gradient's still positive because you're getting positive values up here. The gradient's 0. The gradient's negative. This is the biggest negative gradient you've got. Still negative. Gradient 0 again. Gradient now has positive values. Gradient down here has negative values. Small negative values. They're the biggest negative values. That's like y equals x squared. When I differentiate it, I get 2x. Straight line. But let's just do it the other way. Tell me about the gradient. Negative and big. Look, negative, still negative, smaller, 0 gradient, positive, and big positives. So negative, negative, smaller, smaller, 0 gradient, small positives, big positives. Let's go. Do your 0 first. Small positive values here, big positive values there. Straight line, because you know that that's an x squared type curve. This will be a straight line. When you differentiate the x squared, you get an x. That's straight line. What about this type of curve? What type? Negative x squared. Differentiate that and you're going to get, differentiate negative x squared. What do you get? Negative 2x. So it's going to be a straight line, but like that. Let's have a look at the gradient. What is it? Positive, 0 gradient, positive, bigger, smaller positives, 0 gradient there, negative and bigger. So I need negative values here that are bigger. I need a 0 gradient there and I need a big positive value there. We know it's going to be a straight line. Okay. Have a look at this. Is the gradient constant? Is that the same gradient all the way? It is, and it's positive gradient. You can do this two ways. You can say the gradient's positive and it's constant. So I can go like this. The gradient is a positive value and it's constant for every value of x. Or you could say, I think this could be y equals x plus 2 or x plus 3. And when I differentiate it, this is what you do in your head, what I'm writing here. You don't really write it on there. You say, if I differentiate that, I get y equals, y dashed is 1. That's about right. Don't go and put a 1 there. It just helps you. Okay? Next one. Tell me about the gradient here. It's negative? Is it the same? Is it a constant gradient? It's a negative gradient and it's a constant value. I mean, it could be negative 1 from what I see. There you go. You okay with that? Look at the type. It's an x squared type, but it's shifted. You don't have to know exactly what the equation is. X squared type, it's shifted. Tell me when you differentiate it, you're going to get a straight line, right? But here, gradient's very steep and negative, smaller negatives, gradient 0. Gradient's positive, smaller, gradient positive, bigger. So at this particular value of x, the gradient's 0. This is an x squared type. When you differentiate it, you're going to get a straight line. So at this particular value of x, you've got big positive values of 0 big positive values for the gradient. At this value of x, you've got smaller positive gradients like this. All good? Next one. Tell me what sort of graph that is from your knowledge, extensive knowledge of functions. Yeah, it's a negative cubic, isn't it? I think that's like a negative x cubed type. I know it's shifted off center. It doesn't matter. But if you differentiated that, you'd get a negative parabola. So we're hoping it's going to look like that. Tell me about the gradient here. Well, that's negative and very steep. And then it's still negative but gets smaller. I don't think... Well... I don't know if I'd say the gradient is 0. It's close to 0. I don't know if I could say definitely. What do you think? If it is flat, it will be 0. If it's not flat, it'll be slightly below. It'll be slightly negative. You might say the gradient's either going to be 0, it might be negative 0.2 or something. But here again, negative, negative, negative. Look, what do you want to go for? Inflection? Do you think it's flat? I don't think it's flat. It's not flat. So the gradient's not going to be 0 there, but it's going to be very small negative value like this. See what I'm doing? If I thought that that was definitely flat there, I'd put gradient 0. But I'm thinking it's a small negative value. Now I've got very big negative values and here very big negative values. So I'm thinking it goes like this. But I'm not going to touch it to 0 there because I really don't think that's flat. I think that's an ordinary inflection. I don't think that's a horizontal inflection. If it was a horizontal inflection, you've got to come up to 0 to say that the gradient, you know, for horizontal inflections, f dash x is 0. We're sketching f dash x. I don't think it's 0. I think it's just slightly, it's just a negative gradient, very small one, but negative. Okay. The next one. All right. This one, you can see the shape is like a negative x to the power of 4 type, right? But this one, I couldn't tell you what shape that one is. I think you've got a triple root there and a single root there. Anyway, let's just play with gradient for these ones and this one as well. Forget knowing what that one is. All right, tell me about gradient, positive or negative. Let's go. Positive. Let's go. Positive. I really think the gradient here is 0. You think that's flat? All right, so we've got bigger positive, smaller positive values. 0. Tell me about now. Smaller positive. This is the steepest. Look, concave up, concave down. That's my biggest positive value there. Then they get smaller. Gradient 0. Gradient small negatives and big negatives. Biggest down there. All right, let's start sketching that. We've definitely got 2 0 gradients. One there. Oh, wait a sec. That's still concave down. We've got a negative, sorry, we've got a zero gradient there. In between, we've got a maximum positive gradient about here at that x value. So it's going to go like this and like that and all negative gradients. Tell me about gradients here. Ooh, positive. Bounces back up. And, oh yeah, like this and like that. I think. But maybe not as steep. Maybe more like this. Something like that. Whatever. Okay. I think like that. All right, this one. Let's mark out the gradients. Positive, 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 0. Negative. Guys, look, concave down, concave up. You're going to have a maximum negative about there. Negative, 0. Positive. Look, concave up, concave down, a maximum positive about there. Still positive, 0, negative, 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 negative. So watch out for those maximum positives and those maximum negatives. 0 gradient, 0 gradient, 0 gradient. Now, see, the other thing is if you've got a 0 gradient here and a 0 gradient there, and it's negative between, it's got to come down and come back up anyway. And here the gradient's positive, biggest positive about there. And now I've got negative gradients, and here I've got positive gradients. You know how we said that's a negative x4 type curve? This is a negative x cubed type. Do you get that? Oh dear, and the last one. All right, let's look for the zeros and the big positives. Big positives. Smaller, 0. Negative, look, concave down, concave up. You're going to have a maximum negative there, smaller, 0. Concave up, concave down. A maximum positive there, a 0 there. Concave down, oh, horizontal inflection, 0. Down, up. A maximum negative there. Got it? Smaller negative, 0. Negative. Maximum negative, down, up, maximum negative. Actually, I'm going to put dots on the curve where these maximum negatives and positives are. And negative, 0, positive, positive, positive. Look for those inflections. I'm going to put those inflections here. There. And there, look. Concave down, and here's one too. Concave down, up, down, up, down, up. So at those, they're going to be your maximum positive and negative values where this curve down here turns. So let's put in all the zeros. I've got a 0 there. I've got a 0 here. I've got a 0 there and here and about there. Now, I've got a maximum negative here. It doesn't have to be that big. Yeah, positive. Positive gradients there. Then I've got a maximum positive there. It's not as steep. So I'm going to have it a bit lower than that one. Then I've got more positives, but not very steep. No, made a mistake. I've got to come back up, don't know. I've got a negative, sorry, but not that steep. Not as steep as that one. So have it coming down, but not as far as that one. Because look, that's steeper. This is negative, but not as steep. So that one has got a bigger negative value than down here. And then, where are we going now? Is it negative again? And steepest negative here. And back to 0 and positive. Wow. Something like that. And I think this may not be as steep, maybe not as far down. Bit hard.